are you doing today? How many people have actually asked you that question? It's a simple question. It's probably the question that we should all be asking one another as we look out for one another. Now, I hope you're doing well, by the way. My name is Matthew Griffin. I'm the CEO and founder of the 311 Institute, a global futures and deep futures think tank looking up to 50 years out and beyond, but mainly 50 years. I cover over 600 emerging technologies, hundreds of different megatrends, and ultimately what I try to do is I try to democratize access to all of the things that I find, help you understand how they can shape the future, how you can build the future, and then understand the impact of everything that we're doing today on that future. Now, as a couple of examples, I've written 15 books. They're all downloadable for free from the 311institute.com website. In this particular blog, we're going to be talking about the latest bleeding emerging technologies that I've seen emerge over the past couple of weeks. And if you really want to kind of play along, then you can download these codexes. So this is the 311institute.com's emerging technology codex. There is nothing like it. It was described by, shall we say, members of the US government as the tech Bible of the 2020s. There are over 350 emerging technologies in this, easily up to 50 years out. So this is where we look at things like molecular assemblers, brain-machine interfaces, liquid artificial intelligences. This is where we go to holodecks, all kinds of different things. So download that codex. If you want to understand the, frankly, furious and curious world that we actually now live in, then maybe this one is the one for you. It's the 311 Trends Codex. Now, these are free. This monster has over 600,000 hand-researched statistics, and they're all presented in a very, very easy to follow fashion. So each trend has its own page, and you scan a QR code and you can kind of find out more and everything else. You can dig into what is the trend, what's the impact of the trend, some examples of that trend, and then, if you're a business leader, how do you actually either lean into that trend or how do you, kind of avoid being hit in the face by it? And then for would-be entrepreneurs, I love helping entrepreneurs. So I've helped recently a couple of people from Pakistan starting their own artificial intelligence company, which is very nice. Thanks. Hey guys, as well as over in Ghana. Then you've got this, how to build your own exponential enterprise. So this is how to go from realistically, a blank sheet of paper all the way through to a fully launched, fully scaled, hopefully multi-billion-dollar business. This one's used by organizations like Samsung, Huawei, and just those two organizations provide a lot of lessons in disruption, which I won't go into, but you should probably know. And lots of other organizations use that as well. So anyway, as I say, my name is Matthew Griffin. Welcome to the future. So let's crack on. Now, when we actually have a look at this, so this is my fanaticalfuturist.com exponents blog. So there are about 5,000 news articles on this. They're all categorized by type, by technology, and so on and so forth. And if you actually click into each of these individual articles, then if you're interested, for example, in the latest artificial intelligence breakthroughs and developments, then you can just click AI and it'll take you through to everything. Same with nanotech, same with whatever the heck it is that you're actually interested in. Cybersecurity, maybe. What I try to do basically with these blogs is I try to provide you with deeper, broader insights into not just the news, but the kind of the news behind the news and how it all sort of ties together. Now, a little while ago, you might have seen one of my videos that I did on DeepSeek. Now, I said in that video that DeepSeek was not a surprise. We actually saw DeepSeek emerging in 2017 for a variety of reasons. So I'll put the link to that video in the timeline and the comments below. But when we actually think about DeepSeek, I've been finding some more information and insights into it. And one of the things that kind of fascinates me is politics. Now, I know that might be boring. I know basically that enough is probably just going to get you to bang your head basically on the desk in front of you. So I apologize for that. But actually, what if DeepSeek went viral around the world, not by accident? Now, in this particular piece of news, there was a Canadian research company. And what they actually found, basically, is they actually found that the Chinese government, and this company is called Graphica, so as you can see, you can click into these different articles, and you can read much more about the topic than I'm going to be sharing here, but I'll give you the good oversights. What Graphica found is that about a few days to a week before DeepSeek hit, should we say, Western news headlines, the Chinese Communist Party and state-sponsored social media accounts, not just like TikTok, not just like Facebook and Twitter and so on and so forth, but also a lot of the Chinese social media platforms like Weibo, had started boosting DeepSeek. Now, if you want a little conspiracy theory, how about this one? So, about 5 years ago, the Chinese government publicly announced that by 2040 they wanted to be the absolute leader in artificial intelligence. They invested about $1.4 trillion, basically under the CCP plan, to invest in the development of bleeding edge emerging technologies, which included artificial intelligence, but also other things like quantum computing and so on and so forth. America started pulling ahead. Now, most governments, especially sort of Russia and China, as well as others, basically are very, very good at soft power. Now, if you're starting to fall behind in a race and you suddenly see that a new development could actually put you back on top, then as a government, you might be interested in making that known. However, consider this. So before DeepSeek actually went truly globally viral, it ended up being promoted across a lot of state media accounts. And we saw the upticks. Now, ultimately, DeepSeek, once it hit the Western news headlines, trashed the US stock exchange by $1.3 trillion. Now, on the one hand, it also put the Chinese AI tech community sort of back into the limelight, technically back on top, as everyone thought it was really amazing. So by publishing all of this social media content before everything went nuts, the Chinese were lining things up very nicely. And that is not just a technological bump, it was also an economic kick to the balls, shall we say, to the US as well. So, and there's more on this in a moment, because the global impact of DeepSeek was not $1.3 trillion. It was a bigger number. Now, speaking of China, we saw China's Manus being released. Now, this particular artificial intelligence from China basically is what we call an agentic artificial intelligence. Now, typically when we're interacting with the large language models like ChatGPT, quite often, and simplifying it a lot, we're not, but simplifying it a lot. Technically, when you work with ChatGPT, you're working with a single artificial intelligence. Now, the difference between large language models, as they kind of are today, and agentic artificial intelligence is, in an agentic artificial intelligence, you will be dealing with a single artificial intelligence that's like a CEO. You talk to that AI and it understands what it is you want it to do. It then delegates a lot of different tasks to individual agents, so we can think of them as artificial intelligence bots, that then work collaboratively together, a little bit like the human gig economy, but this is more of a machine gig economy, to get something done. Now, when we think about agentic artificial intelligence adverts from lots of companies like Google, for example, they will show off agentic artificial intelligences that will, find the best restaurant for you, book that restaurant, they will find the best holiday for you, they'll book all of the hotels and airlines for you and the tickets for you, etc., etc. So in the context of digital assistants, agentic artificial intelligence, you can think of it very much as almost having your own concierge. It's a case of, I want to go on the best holiday that I possibly can, and the AI comes back and goes booked, which is very nice of it. Now, with this particular one, Manus, the Chinese Manus agentic AIs basically were classed as, by the developers, as being the world's first fully autonomous artificial intelligences. They also said that it was putting them on a path to develop artificial general intelligence. However, they weren't the first fully autonomous. And again, the news blew up because everyone picked up on the fact that, these are the first fully autonomous AIs. They're not. Arguably, the first fully autonomous artificial intelligences that we saw that were actually kind of in the agentic era was AutoGPT, where about 3 years ago, someone actually took lots of GPT agents, got them to collaborate with one another to perform particular tasks. So that was one, principally coding. Then we also saw Devin. So Devin, basically, was about 2 years ago, was ostensibly promoted as the world's first fully autonomous software developer. And that particular company went from $0 in valuation to about $3 billion in valuation in the space of a month. So I think my takeaway here is while Manus itself is very, very impressive in what it does as a concierge, you really have to dig below the headlines because there are so many headline statements that people are making. This then gets picked up by the regular news media that then goes, this is amazing. It's the first time this has ever happened. And it's not. That's it. But the fact that people think that this is the first time this stuff has happened then just hypes it up even more. Now, talking about agentic artificial intelligences, one of the big problems that we have with agentic AIs is I will ask the boss AI to do something for me. It will, as I've explained, delegate that task or those tasks to AI bots and agents to go off and do things. Now, the delegation of those tasks to the AI agents is what we call an agentic workflow. So this is simply the flow in which different tasks are handed off between different agents and so on and so forth. Yeah, you get the gist. Now, one of the big problems, well, actually two of the big problems that we have with agentic artificial intelligence and agentic workflows are, on the one hand, unless you've got tools which don't really exist yet, you don't know where those individual AI agents are. So you could ask an AI agent to write to you a report on the state of a new market, and the AI agent that starts writing that report and collaborates with others could be based on a North Korean server. So on the one hand, we have no idea where many of these agentic AIs reside. We have no idea and really no way to tell whether or not they are biased, whether they have been hacked and compromised using, data poisoning techniques and so on and so forth. So that's a risk. But thirdly, we don't really know how, on the one hand, how they actually interact, and we don't know what they're good at, what they're bad at, what biases they might have, and so on and so forth. So DataBricks is interesting here because while we've seen agentic artificial intelligence platforms being released from companies like Salesforce with Agentforce, but also Workday, DataBricks are using synthetic data to try to evaluate agentic workflows and agentic AI. And over the past year, I've seen a huge uptick in the use of synthetic data to train artificial intelligences and to do different things, whether it's for AI world models, as I explained in the last video blog when we were talking about Google and NVIDIA leaning more heavily on world models, or whether it's in the use of the development of new trading algorithms and so forth. So I've been tracking synthetic data really for about the past 7 years. And this represents a whole new frontier because increasingly, if we don't have the data, we're making the data. And then there's got to be questions over the authenticity of that data, the biases built into that data, and so on and so forth, which again, we're not really as a society actually even considering. From an AI development perspective, there are those basically who actually kind of say junk in to an artificial intelligence and junk out. And yeah, frankly, I really don't know how much we should be trusting and or relying on synthetic data to train models and figure out the behaviors of artificial intelligences when we don't really understand some of the nuances of the data sets themselves. If that makes any sense, frankly, which it probably doesn't. Now, I did say to you that, while we saw DeepSeek destroying $1.3 trillion of US stock exchange market caps and value, interestingly enough, 7 days after it had destroyed $1.3 trillion, we saw this. We saw the Hong Kong Stock Exchange increase by $1.3 trillion. But that's not all. We also saw the Indian Stock Exchange fall by around $700 billion. So when everything was said and done, DeepSeek moved global markets in the space of a week by around $3.4 trillion, which is staggering. Now imagine the impact of that on pensions, investments, savings, all kinds of different things. Now, the reason why we saw these swings is because on the one hand, we saw the US stock exchanges dive by $1.3 trillion for the simple fact that a lot of people thought DeepSeek represented a clear and present disruptive threat to the established big foundational models like ChatGPT. So very briefly, ChatGPT costs $200 million to train. DeepSeek costs $5.6 million to train. It's not necessarily a surprise, basically, that happened. We also saw Stanford training artificial intelligences like ChatGPT for $600 in 26 minutes. So this is why I say DeepSeek wasn't necessarily the amazing breakthrough that the generic news media sort of like to make out. But anyway, as investors questioned whether or not they should be pumping tens of billions of dollars into these large American foundational model companies, as well as companies like NVIDIA with their GPUs, the stocks in America fell. Now, the stocks in India also fell because investors started increasing more in Chinese stocks. So what they did is they took money out of the Indian stock market and put it into the Chinese stock market as well, because they were concerned that the Indian stock market was going to underperform as a consequence of, what the impact was on the US stock market. So overall, DeepSeek, a $3.4 trillion shift. Stunning, absolutely stunning. And then if you think that some of that could have been engineered, with the story that I talked about earlier, I mean, wow, that is the age that we live in. And if you have a savvy government, then what else can you do with a couple of social media accounts and a AI bot? Anyway, next, sticking on the sort of Chinese theme, the Chinese have now, it turns out, developed invisibility cloaks for drones. Now, when we think about invisibility cloaks, on the one hand, we think about Harry Potter-like invisibility cloaks. I've talked about those before. I've shown those off before. So we do have what we call optical metamaterials, which are able to redirect light around an object to make that object literally look invisible. And you can actually buy invisibility cloaks for a few $100s on Kickstarter, but that's a kind of different conversation. Now, what we've got here is, over the past couple of years, I've seen the Chinese government, through the Chinese Academy of Sciences, leaning very heavily into the development of new metamaterials. Now, we've got acoustic metamaterials, digital metamaterials, telepathic and telekinetic metamaterials, which are crazy. They're in the book that I mentioned earlier. But in this particular case, Chinese have developed not only optical metamaterials, which you can apply to a drone so that you just can't see it. They've also applied electromagnetic and acoustic metamaterials. So the acoustic metamaterials mean that the drone redirects sound in a rather strange way, but the electromagnetic metamaterials mean that you can arguably fire a radar at these drones, and these metamaterials very effectively curve those radar waves around the drone, so it is pretty much completely invisible. So when you think about metamaterials, think about stealth in terms of military grade stealth materials and technologies and fighter planes and drones on steroids. So what happens when you have something the size of a DJI drone that is covered in a whole host of really digital metamaterials, and digital metamaterials are tunable, so you can change the characteristics of those materials. What happens when you can't see or sense or identify or detect these tiny drones at all? Yeah, I mean, that gives the American military an even bigger headache than they had before, especially when you consider that China is trying to develop hypersonic swarms of drones, as I've again talked about before. And if you want to know more about hypersonic drones, then again, just go and search the fanaticalfuturist.com website, and you'll find lots of different things on that. So Google, now again, I've talked in the past about teams in Japan that have been trying to develop fully autonomous AI scientists. So this is really the use of artificial intelligence to automate the scientific discovery process. And this is where you say, create something new, innovative that no one has ever thought of before, and the AI sort of goes off, figures what the problem to solve is, does a lot of research, and kind of then creates a product and goes, here's the product. Now, while there are different organizations around the world that are trying to automate the process of science and scientific discovery, Google's kind of leaning in a slightly different direction. So Google is trying to use their reasoning research AI to give scientists superpowers. Now, what we actually mean by that is Google is ultimately trying to help scientists do their work faster, more effectively and efficiently for lower cost, so that they can have more scientific breakthroughs. And actually, I think that's a very interesting way to go. And a lot of the scientists that have used Google's new sort of science co-pilot tool have been absolutely amazed by what it does. And inevitably, this AI has actually come up with with a variety of new sort of breakthroughs, especially in things like materials as well as genomics. So you can read into that if you like. Right, here we go. Now this one, recently, basically we've seen Tesla coming under immense fire, literally fire. Especially in the United States, we've seen Tesla's stock price dive from about 1.4 trillion down to about 600 to 700 billion dollars, which is giving shareholders enough of a headache. And however, we've also seen the likes of Cathie Wood from ARK Invest saying that while Tesla's share price today is in the toilet, she thinks that the share price will go towards $2,600 because ultimately Tesla is going to be bringing out fully autonomous robo-taxis soon. Now, for anyone that doesn't know, a fully autonomous robo-taxi is very much akin to the things that you see in San Francisco and Austin in Texas. Basically, they're taxis without drivers. You just get into you call the cab like an Uber, you get into these self-driving cars, and they just drop you off at their destination. Now, when you start digging into the economics of self-driving cars, it's estimated that Tesla at the moment, for example, make around $700 in profit for every car they sell once the customer's bought it. However, if Tesla do not sell that car, then the lifetime profit value of that car as a self-driving taxi, where Tesla can charge you to be in the car as it takes you from A to Z, is estimated to be between $30,000 to $50,000 per car. So when we actually have a look at Cathie Wood and ARK Invest, they're looking very much on that side of the economic spectrum and saying, well, today Tesla makes about $700 per car, but with a robo-taxi, Tesla could make $50,000 in profit per car, and then you multiply that up across the fleet and you suddenly get a much higher share price. However, when we actually have a look at BYD, BYD is interesting because on the one hand, they are manufacturing electric vehicles 30% cheaper than anyone else on the planet. But they also have an electric vehicle which is around the $9,500 mark. And because it's already packed full of sensors, they've actually been giving full self-driving features away for free for electric vehicles that cost less than $10,000. I mean, can you imagine being in America and actually picking up an electric car basically for less than $10,000, let alone one that actually has category 3, sort of full self-driving capabilities, so when we talk about self-driving cars, there are 5 levels, level 1, 2, 3, 4, 5. And at the moment, generally, we're sitting at 3. But when you get to 4 and 5, this is pretty much where the human does start going out of the loop, and you can be sitting in the back of the car having a nice massage, watching Netflix, or Mercedes-Benz's own in-car entertainment system while the car, does its thing. So that's interesting because BYD is fundamentally rewriting not only how technology is used and deployed, but it's also fundamentally rewriting the economics of the future car industry. Because do you use a Tesla if you're looking at a fully autonomous robo taxi fleet? Or do you spend $10,000 or less buying a BYD version of that? For most companies, outside of the fact that BYD is Chinese and the American government say that there are a lot of national security concerns for a lot of people, a $10,000 car that drives itself, that's cheap. That's a nice on-ramp. So anyway, next. I also do a lot of I do a lot of research into display technology. I don't talk about it much. A little while ago, I was talking about atom-thin flexible displays that we've actually seen being developed in the United States and so on and so forth. But recently, we've seen BOE, which is again a Chinese company, developing and releasing 16K ultra high definition televisions. Now, for those of you that aren't necessarily aware, a 16K TV has 16 times the number of pixels as a 4K TV. So while these TVs, when you start getting to 8K and 16K TV resolution, something odd starts happening. Now, on the one hand, once you go beyond 8K, the human eye fundamentally just can't see anything better than that. So when you go to a 16K resolution TV, as far as the human eye is concerned, there's not really much difference. But as you start getting to 8K and 16K TVs, the human eye starts seeing what they call a natural 3D effect. So this is where you end up with 3D TVs or stereoscopic TVs without having to wear the glasses. So while there are some insanely high resolution display technologies actually coming through, on the one hand, it highlights basically the progress of technology that we're actually making. But secondly, the human brain kind of just goes, yeah, it's great, it's a 16K TV, but frankly, I don't know the difference between a 16K and an 8K TV. So kind of, is this really innovation for innovation's sake? I don't quite know where we go with 16K TVs. I don't really know what the killer application of a 16K TV is over an 8K TV, but maybe the Chinese do. Now, skipping to America, that's it. So as an emerging technology sort of futurist, I have to say a lot of some of the latest emerging technology breakthroughs are inevitably more Chinese or more likely to be Chinese than American or European. It's sad, but kind of true. But as I say, skipping back to the United States now, I've been tracking the progress of a company called Boom Supersonic. So Boom Supersonic is the first company to try to develop, the first private company to try to develop supersonic aircraft. Now, what they want to try to do is they want to try to create a supersonic version of Concorde. So Concorde ended up being mothballed basically in sort of the 1980s, early 1990s. But Boom Supersonic have now got around sort of $3 to $5 billion worth of orders from companies like United Airlines, American Airlines, and Japan Airlines for their supersonic passenger jets, which will allow you to get from, for example, London to New York in about 4 hours and so on and so forth. Now, in this particular piece of news, they have just flown the first ever private Mach 1.1 prototype. So while it takes a huge amount of money to develop a supersonic aircraft, they're actually on a decent trajectory. I hope they don't run out of money before we actually start seeing some of the first supersonic aircraft actually rolling off the United Airlines runways, allegedly in 2027, 2028. So I was having a conversation with the United Airlines CEO in Vietnam a little while ago, and they've ordered about 60 of these, and they think that they can hopefully, fingers crossed, get them actually into the skies for passengers to book tickets on really sort of by 2027, 2028. I think it's a little bit optimistic looking at some of the timelines, but it'd be nice to actually go and fly supersonic somewhere. I do far too much plane travel. And then, looking at India. So I've been doing a little bit more research into India. India was turned upside down by DeepSeek, just as the United States was. And there were a lot of people in the Indian market that just simply said, where are our AIs? As India, we have 1.5 billion people. We have some very big technology companies like, Tata, HCS, Infosys, those kinds of guys. Why aren't we on the global stage here? So India and Europe kind of, wondering, why is everyone talking about everyone else, not us? But India's Reliance CEO went on record actually this week to announce that he was going to create India's biggest data center. And everyone was like, that's great, that's great. What is it? What's it going to be? How much is it going to cost? And he said, I'm not going to tell you. So if you want to develop the world's biggest data center, we generally think that to develop the world's biggest artificial intelligence data center, you really need to be investing in the order of $5 billion plus. You've got to be looking at around 300,000, GPUs, typically NVIDIA GPUs at least. And if it's really going to sort of be, the world's biggest AI data center, then, you've really got to be looking at an AI data center with probably in the region of about 500,000, say, Blackwell GPUs. You've got to be looking in about the 1 to 2 gigawatt energy range. It'd be a monster. But the fact of the matter is we don't really have many details on it yet. It's all very well announcing these bold plans. We saw the United Arab Emirates, we saw DAMAC, also talking up about investing billions of dollars in developing AI data centers actually in America, as well as kind of in the Middle East. So we're seeing this kind of war bubble up. We're also seeing BlackRock, for example, the global asset manager with about $13 trillion under asset, actually investing quite heavily in the build out of data centers around the world. So evidently BlackRock sees a big opportunity to make lots of money and be a big dominant player in the data center industry. They've generally now poured many billions of dollars through a sort of an associate joint venture they created. It's not BlackRock directly, but they kind of created an affiliate company and they're funneling everything through that. So when we think about some of the game-changing AIs that we've actually developed using, 1,000 GPUs in the case of DeepSeek, but also sort of 200,000 GPUs, as is the case with OpenAI's ChatGPT, or 300,000 GPUs, as we've seen with Grok 3, as I've talked about before. Then, what kind of AIs can we actually expect when we see the amount of global compute capacity tripling over the next sort of 5 years? This isn't the only piece of news on data centers. And again, you can click into this particular article, click the word data centers, and then you can see all of the latest, greatest developments. And I say news, but, greatest developments basically in data centers around the world. Now, earlier I was talking about my emerging technology codex, the big thick thing. There we go. Now, in here, we talk about liquid artificial intelligences, but I also talk about liquid computing as well. This one here is a new kind of computer that, frankly, I don't think anyone is really paying any proper attention to. Now, it hasn't got a name. I've been tracking this for about the past 3 years. I call them meta computers, not because they're made by the company Meta, but because they are computers that are made essentially in the metaverse. So there is a guy who has been developing computers in Minecraft worlds out of redstone. Now, if you think about this, you've got Minecraft as a game. You create a computer within Minecraft that can run an artificial intelligence that's also made in Minecraft out of redstone. That's nuts. However, over time, this slow, chunky looking technology that no one really pays any attention to starts getting faster, more efficient, more effective at what it does. So now this is where within Minecraft, we have the possibility that AIs built in Minecraft can design better computer platforms that run in Minecraft, that run better AIs in Minecraft. And then you repeat that infinitely. And now what you have is you have the ability to create artificial intelligences and massive, massive global distributed compute within almost any kind of gaming environment. Now, what that does for our reliance on physical data centers, like the one I just literally talked about here, I'm not too sure. But this, for example, when we talk about India building out an AI data center, that is a single data center where, shall we say, artificial intelligence training is centralized in one place, to all intents and purposes. This meta computer could actually see anyone on Earth accessing Web3 like distributed compute at massive scale to train an AI. And I would argue there is more compute potential in this one, in meta computing, than in this 300,000, 500,000 GPU monster data center. So, as I say, this computer basically at the moment is running at about 1 hertz, 2 hertz, very slow. These are the technology moments basically where you look at an individual technology and you go, it's shit, no one's going to use it, it's too expensive, too complicated to use, there's no programming interface, never going to do anything great. And then in 10 to 15 years time, this starts becoming popular in the news. And then all of a sudden in 20 years time, this is the only thing that we're using. Yeah. An example of that is generative AI. So 10 years ago, actually, well, in 2016, I was talking about a new thing called generative artificial intelligence, and again, exactly the same thing in London. We were going, the images, the text to image that these AIs are generating basically is rubbish, very expensive, no one's going to use it, etc., etc. And eventually, generative AI, the only thing that did, changed the world. Yeah. And then, we've talked a little bit about Tesla in this video blog. Let's cut across to SpaceX now, just completely randomly. So Elon Musk, love him, hate him, loathe him, whatever. He does lean very, very heavily into the latest bleeding edge emerging technologies. I mean, the examples of this are things like Neuralink, basically, which is a brain implant company that ultimately, by the looks of things, he wants to use as a foundation to enable human-to-human telepathic communication. I'll get into some bonkers stuff. That's a conversation in itself. But, he's also wanting to land on Mars. He's also developing some of the most sophisticated AIs on the planet. He gave $100 million basically to the X Prize Carbon Prize to suck as much CO2 out of the atmosphere as possible. So Elon Musk really leans heavily into the latest emerging technologies, 3D printing for his rockets and so on and so forth. The latest optical technologies, basically for Starlink, the global communications constellation, 12,000 satellites in space connecting everything on the planet. Now, interestingly, the next thing that he's actually been playing around with is quantum technologies. But rather than trying to develop quantum computers and so on and so forth, which I think would kind of be a natural next step, basically, for a guy like Elon Musk, even though others are doing it, and it might be a bit of a distraction for him, as these things will take a little bit of time to commercialize. He and SpaceX are now starting to explore the theoretical possibility of bringing intergalactic teleportation to life. Now, I follow teleportation. Again, go into the article, click teleportation. You'll see some of the latest sort of news snippets there. We have been able to teleport data over huge distances. And this isn't transmitting data. This is teleporting data. Literally like we see in Star Trek. You know, the data is here and we literally go, and then it suddenly teleports itself over here. We've seen the development of what we call magnetic wormholes, basically where, you know, you've got a magnetic force here, you've got a magnetic force here, but actually there's no magnetic force in the middle, you know. So we have done some rather weird things when we think about, you know, teleportation and moving, I won't say matter because magnetism isn't matter, but, you know, moving, should we say, I don't know, what the hell is magnetism anyway? You know, moving magnetic fields from one place to the other and teleporting data from one place to the other. So I still think that the ability to teleport humans is easily 100 years out. It requires huge amounts of energy, which is where some people have been talking up the use of Dyson spheres. From an artificial intelligence perspective, you probably at the very, very least need an artificial super intelligence that is plugged into a Dyson sphere. So, I mean, good luck to him. I mean, inevitably, this is a piece of interesting news to watch. We'll see where that one goes. But certainly, when I'm doing my keynotes, would I like just to be able to teleport from one side of the planet to the other? Absolutely. But I would also like to be teleported to the other side of the planet in one piece. And then would I actually still be myself? There are all these theoretical questions that lots of people are actually asking as we start talking about the development of human teleportation. And then with that, that is the end of this little video blog. I hope you enjoyed it all. As I said, the only thing I talk about is the future. And when we actually have a look at the future, generally I'm looking at beyond the bleeding edge and digging into the big topics of the day that matter. Makes me sound like a news anchor. So if you want to go and explore the future some more, go and download these kinds of monster books. So go to www.311institute.com. It's all free. There's a little bar at the top. You can mooch about my YouTube channel. There are now 200 individual keynotes, basically on pretty much every single topic. On there, I'm going to be loading some more up today. And I hope you well. That's it. Have a great future. And hopefully I'll see you again in the future. Take care. It's goodbye from me, and it's goodbye from me.